Did you damage your exotic carbon bike in a bike crash? Well, it is not trash. I'm going to show you how to fix it step by step right now. Hey friends, it's Brian and I'm back in the garage again today. I have a super cool project to share with you. We're going to repair this damaged Pinarello F8 that was involved in an unfortunate little crash. What we're going to do is repair this, and I'm going to show you step by step exactly how to do a repair on a bike like this so that you can do the exact same job at home. So before we get started, I know most of you guys know me as a motorcycle guy, and I do obviously a lot of motorcycle stuff, but I also have had a very long career in racing. And I was one of the early people doing composite jobs on race cars back in the 80s. And back then I was making wings and underbody diffusers and all kinds of things. And I also made this cool form-fitted seat for my shifter cart that I actually created from a mold of my body. And because I was kind of one of the early people in this composite field, some of my work was even published in some magazines. So I've been doing this a really long time. So a couple things I wanted to tell you about composites. There are lots of videos out there on composite repair, some of them good, some of them not so good. And the thing is there's always someone criticizing the content creator for making what they perceive to be a mistake or something like that. So I want to just tell you that there are a number of ways to do carbon fiber repairs. There's not just one system. So I was trying to think of a good comparison, and I was thinking about like making bread. So let's just say that you worked in some bread factory and you were asked to make a high quality loaf of bread or a bunch of bread, and you've got at your disposal ovens and mixers and the best ingredients and everything's right at your disposal. Well, you can make some fantastic bread in that environment, of course, but if you're just a person who wants to make a loaf of bread at your house, you might have just a hand mixer and crappy ingredients you got at the grocery store or something basic like that, but you can still make a really good loaf of bread at home. So the point that I'm trying to make is that there's a lot of exotic products that are used, or componentry that is used to build a frame like this one, such as an autoclave, pre-peg carbon fiber. There's a number of other things that are just too exotic really for the home craftsman, but there are systems out there created just for people like you and me who want to do this kind of job on a small scale at home, making our one loaf of bread at a time. So feel confident that even if you don't have an autoclave and all those other things I was talking about, you can still produce an outstanding result that is completely imperceptible, that it's ever been damaged, and also as strong as the original component. So I want to tell you another couple things. I know there's a lot to say here, but the techniques that I employ were popularized by a guy named Burt Rutan, and the technique is called moldless composite construction. If you haven't heard of Burt Rutan, you've probably heard of Spaceship One. Spaceship One was the first piloted spaceship of a private nature that ever made it into suborbital flight, something like 330,000 feet. So Burt Rutan was the winner of that $10 million X Prize for successfully launching that plane. And I strongly advise that you get his little pamphlet or book. It's somewhat hard to find these days, but you can get it on eBay. And anyway, familiarize yourself with the techniques that he uses. So I'm using the techniques of moldless composite construction as taught by Burt Rutan. And one other thing you should know is that there have been some developments in terms of some of the products that are available that were not made at the time that this pamphlet was created, but that we will be employing, the most notable of which is a compression tape, which they didn't have back at the time that this book was published. You can absolutely do this job at home. It's not super easy, but like I said, if you can follow directions and do the things that I said, you can absolutely do it. So I think that's all. Let's go clean up the shop, get ready to do some work, pick up some tools, and let's do some carbon fiber. So the first step is to examine the damage to determine how much of the area is affected. The owner stated to me that he was hit on the right side and then fell over to the left, but he was not really sure about what actually caused the damage. To me, it looks like the seat stay was hit from the back and pushed forward, causing this crack along the leading edge, but the owner says that's not the way that it happened. So a little bit of a mystery there. Regardless, there's a piece of paint or carbon, something like that, missing from the trailing edge that extends upward towards the proximal end of the seat stay, and a radial crack penetrating just past the midline of the seat stay on the leading edge. So all in all, not really that bad. It wasn't smashed, just kind of a juicy little crack. Since we're going to be sanding, it never hurts to protect the area around the repair so you don't accidentally scratch it with some sandpaper. So I'm just putting a little bit of pallet wrapping plastic around the frame to protect it, and then using some gaffer's tape to hold it in place. Then near the dropout, I'm just wrapping this area with gaffer's tape. So once we've masked off the area separate from the damaged area, it's time to prepare the surface. I'm going to start by sanding the surface with some 220 grit sandpaper on a flat sanding block. And in an effort to expose the maximum amount of bonding surface, the substrate is prepared using a sanding technique called scarf sanding. Now, scarf sanding is a technique that creates a very gentle taper, exposing the plies gradually, yielding the maximum surface area for the repair plies to adhere. To demonstrate what I mean, I made this little graphic. So imagine looking at the seat stay from the side in cross section. These two represent 3 carbon layers that you would see with the damaged section between them removed. Notice the gentle taper of the exposed plies after sanding. This is the scarf sanding technique. Once you've achieved this taper, the surface is cleaned and prepared to accept the new carbon plies. You start by laying up the largest ply first, then each successive ply should be slightly smaller. Finally, once all the plies are cured, you can fare them down by sanding them until the new plies are in the same plane as the surface. So this graphic's a little bit lacking. I should have made the repair plies a little bit thicker, but you get the idea, and for demonstration purposes, I think you'll understand. The point is, the largest pieces first, then sand them to bring the plies into the same plane as the original part. Carbon dust is not safe to breathe in, so you should always wear a respirator when sanding carbon. You don't have to wear these nitrile gloves, but most of the time I think why not? I mean, if for no other reason, I just don't like dirty fingers. If you're doing a large repair, using a Tyvek suit is not a bad idea either. The carbon can be really irritating to your skin. If you look closely here, you can see all the layers exposed in a broad taper. I didn't sand the bottommost layer completely through except where it's been damaged by impact, but this thing is wafer thin right here. This section in the back had a big chunk missing, and all the fibers in this area were damaged and had to be removed. Since we had to remove all the shattered fibers, we have a nice little hole in the frame now that needs to be filled. There's a number of ways this hole could have been bridged, including making a mold of the shape before we sanded it, but because no cables passed through this component, I decided to go with a pourable foam. It's really lightweight, easy to shape, and since it's not bonded to the interior of the strut or the seat stay, it won't affect the performance of the bike by stiffening up this member. Pourable foam is a 2-part system called Part A and Part B. To mix the two, you need some sort of clean and see-through container like these that I salvaged from some protein powder containers. With this system, equal parts of each component are called out. Measure out equal amounts of each component and take your time to get it just right. Inspect the ratio by eye before you mix the two, and once you're satisfied that you poured the right quantity, mix the two together, making sure to scrape the sides and bottom of the container thoroughly and mix the 2 parts together completely. Once you've mixed the two, do not waste time. Pour the mixture into the cavity. As you can see, this stuff expands pretty aggressively at something like 30 times its liquid volume. After about 20 minutes, the foam is cured, and at this point I use a keyhole saw to rough cut away some of the excess foam. Once you have the bulk of the excess foam removed, it's time to sand it smooth. One little tip on sanding foam. Foam is obviously much less hard than the carbon substrate, so it's easy to sand the foam below the plane of the component face, and this isn't a terrible mistake, but it will mean that you'll have to fill in the depression with more carbon, and it just makes more work for you. So once you're getting close to evening the surface out, start to stay away from the foam. Finalize its profile last if you can. All right, friends, so now a word on epoxy. So the epoxy systems always come in 2 parts. In my experience, they always come in 2 parts. So you have the resin component and the hardener component. Now hardeners, some hardeners you can buy will set at different times. So like 30 minutes, 60 minutes, things like that. So you can buy hardeners specific to your job. But one thing I wanted to mention about that is, like, once you mix up your epoxy, you need to be ready to work like right then. So you've got to be really prepared. The reason for that is that if you start to exceed the time limit of your hardener, the epoxy starts to kick, they call it, which means it starts to turn kind of gummy and it's starting to basically set. So once the epoxy starts to kick, you are pretty much done working. So if you're in the middle of a job and your epoxy's starting to kick, you don't realize it yet, but you're done working. So you always want to plan ahead and make sure that you've got everything ready to go. One other word on epoxy is that usually epoxies are either mixed on weight or volume. And I have always relied on volume, and I'm going to go into a little bit more detail on how I do that in just a minute. But the next thing I want to go over is something that's really, really fun, and that is the carbon. So carbon, you just can't imagine how many different weaves and weights and so forth, things that this carbon comes in. It's just myriad of choices that you can get. And this bike in particular has a super exotic carbon called 1K. Never worked with this before. You can kind of see maybe there that's really thin. This is a really thin carbon fiber, but that's the stuff that Pinarello uses on their bikes, or that's as advertised. So anyway, so always do the research and figure out the exact right carbon for your application. So now I want to go into a little bit of the engineering that kind of makes this carbon stuff kind of sexy and fun, and that is the loads. So on something like a seat stay, when you're getting ready to do your layup, you need to know, and I'll explain in a second, you need to know the direction of the forces that the component is going to be subjected to. So in this case, if you think about it, a seat stay more than likely is going to have some compression forces and extension forces, like going over bumps and things like that. Conversely, it does not have twisting forces, or it shouldn't have twisting forces. It's not that type of part. This is not something that's going to be twisting or anything, like for instance your bottom bracket. The bottom bracket is being pedaled and twisted all the time. Now this is all really important because the orientation of the fibers should be in the plane or the direction of the load. So see how these lines are going this way? Well, this would be the orientation for this piece of carbon, not like this. If you had torsional forces, you would want some of your carbon pieces to be laid up at this angle. So in this case, they're all pretty much in this angle or this direction in this repair, because this is the direction of the load. So something to keep in mind on your repair, just kind of think about those types of things. What kind of loads is your part going to be subjected to, and make sure that you lay up your carbon in the correct way. The book that I went over earlier, Bert Rutan's book, goes into this in a lot more detail, but it's something you should read that. But this is really kind of enough for this repair. So now what we're going to do is we're going to get ready to do this layup. So when we come back, we're going to get all this stuff ready and start laying up some carbon. So with the carbon weave orientation established, the next step is to determine the size of the pieces that you're going to use. So I'm using some painter's tape to hold this carbon still, but you can find the size you need in any number of ways depending on your particular job. Cut your plies to size, recalling that the first ply is the largest and must cover all of the scarf sanded surfaces. Any sharp and sturdy scissors will cut carbon. I've gone ahead and cut all the other carbon plies, and as we discussed earlier regarding the scarf sanding technique, each successive ply is slightly smaller than the one below. With the carbon sanded and the profile created after sanding the pourable foam, the next step is to prepare the surface for the carbon layup. Start by removing the gaffer's tape that we use to protect the frame while sanding. With the seat stay fully exposed, we need to cover the adjacent areas to protect them from any unexpected epoxy drips. Plastic wrap will work just fine. Paper, however, is not suitable for this purpose because epoxy dripping onto the paper will just glue the paper to your substrate, so you don't want that. As a final step, clean the surface using something like acetone or wax and grease remover and a clean cloth to get the surface ready for the carbon layup. Tomorrow's epoxy day, so before I leave the shop, I set the thermostat at 77 degrees, which is the ideal temperature for mixing epoxy. Earlier, I mentioned that I prefer to mix epoxy by volume as opposed to weight. I just prefer volume, and this is how I do it. The epoxy is mixed in a ratio of 100 parts epoxy to 45 parts hardener. Measure 1 inch, that equates to 100 parts of resin. Then for the 45 parts of hardener, start at the ½ inch mark, which would be 50 parts hardener, and back it down about 10% short of that to get the mark for the 45 parts resin. Obviously, you can adjust all this if you need to, more or less, depending on how much epoxy that you need for your job. So this is an important tip. Whatever container you use, it must not be made of a material or coated with a material that could possibly mix with epoxy. So the cup I'm using is a waxless cup made specifically for mixing epoxy. And here's another tip for you. Resin is lower viscosity than hardener, so pouring resin first makes mixing much easier. If thick hardener was the first component to come in contact with the walls of the container, you'd find it much harder scraping that thick hardener from inside the container when the resin and the hardener are mixed together. So carefully measure out each component. Mix the two together for at least a few minutes, scraping the stick, the sides, and the bottom repeatedly. The final mix should present with a completely uniform color. With all your carbon pieces laid out near you in order, your compression tape and gaffer's tape at the ready, and your epoxy mix, it's basically showtime. So there are a number of ways to introduce the epoxy into the carbon. You can dip the carbon into the epoxy, or you can wet the substrate first. In my case, I did a little of both. In the end, you don't really need more epoxy than is necessary to completely wet out the carbon with no dry spots. And oftentimes you'll find that you need to use a squeegee to get some of the excess epoxy out. And again, variations and techniques are covered in great detail in Bert Rutan's book. I strongly suggest that you get that. As we went over earlier, each successive ply is somewhat smaller than the ply that precedes it. If you start to get a little bit messy like this, just keep your cool. As long as the epoxy hasn't started to set, you're okay. It's easy to get excited when it seems like things aren't going quite right, but just be calm. It may look a little bit messy now, but as we start to apply the compression tape, it'll all straighten up. Tightly wrap the compression tape in slightly overlapping wind, kind of like the way you do bar tape on a road bike. Once it's wrapped to the end of the repair, cut to size. To hold the compression tape, I'm using gaffer's tape at each end. The aggressive adhesive of gaffer's tape makes it perfect for this application. Now it's time for some magic. This compression tape is amazing. So using a heat gun on a low setting, work the compression tape back and forth, squeezing out the excess epoxy until the tape is fully compressed. You'll be able to tell when the extra heat is not causing any additional shrinking. Once that's done, the only thing left is to leave it alone and let it cure. All right, so we've let the part sit up overnight, and now we're gonna take off this compression tape. But before we do that and give you the big reveal, I'm gonna take a quick break. We'll be right back, and then we're gonna show you how this repair turned out. Before we pull off this compression tape, it's always good practice to check the quality of your epoxy mix. To do this, take the container of cured epoxy and scratch it with a knife. The knife should yield a dry white line. If it's gummy at all, your epoxy's bad, your ratios were incorrect, or your shop temperature was out of range. Now time for the big reveal. Peel back the compression tape. The compression tape is just amazing what it does. It's like having a vacuum bag. There's obviously no big trick to this. Just peel back the gaffer's tape, unwind the compression tape, and there you go. Man, this thing turned out really nice. Now we're gonna go to sanding. Rough sand the repair with a fairly aggressive grit, and sanding is pretty straightforward, but there are a few mistakes that are easy to make. Once you get the shape somewhat close, you need to slow down just a little bit, and somewhat obviously, as the closer you get to the original contour, you're going to want to move to successively less aggressive grits. The trick is don't over sand. This repair is made up of several plies of very thin carbon, and it's very easy to get overzealous and sand right through a ply, necessitating a second layup in order to get the required thickness to maintain the strength of the repair. A good repair will recreate the original contour with near identical cross-sectional thickness as the original component with the fibers in their original orientation. In my case, the compression tape tweaked the fiber orientation just a little bit, which honestly is not ideal, but I do have several layers under the visible layer, so the strength of repair should be just fine. The final touch is to protect the job with a UV resistant coating. Epoxy doesn't like sun exposure, so it's a good idea to coat with some sort of protective paint. The trick with virtually any coating is providing a clean substrate so the paint will be applied to a surface free of contaminants that might keep the coating from adhering. Acetone works great for this purpose, and always use a clean, lint-free cloth for cleaning. Next, mask off any areas that you don't want painted. I'm using plastic, but in this case, paper is just fine. I just happen to have this plastic laying around. Finally, with clean gloves on, give the area to be sprayed a final wipe down and make sure that no oil or fingerprints are left on the surface. The last step before spraying is to go over the surface to be painted with a tack rag to pick up any bits of lint or dust that may have been left behind. Nothing too tricky about spraying paint, just keep the strokes even and don't overdo it. Give the paint a chance to cure, then remove all the masking to reveal the finished product. Man, it really turned out great. If this were painted to match the original color scheme, you could never tell that it had ever been damaged. And this may seem like a really difficult job, and honestly, it's not that easy, but if you do a little research and take your time, follow along carefully, there's no reason why you should not expect similar results on any repair project that you take on. I mean, everybody had to start somewhere, so I hope you have the confidence now to at least give it a try. All right, so that really turned out extremely good. I am so pleased with that result. And it was a lot more work than I was expecting, to be honest, but it turned out really, really nice. So we've got a lot more videos coming in production, and I hope that you'll stick around for those. It might be easier for you to subscribe. Feel free to do that. Of course, we love to have subscribers, but more videos coming soon. Also, I just want to tell you that you can definitely do this job. I know I mentioned that a lot early on, but one of the things I really like to tell people is that, you know, what good is a video if you're not willing to try? So don't be afraid to pick up your tools and try to do this type of repair. You can do it if you follow along and do the things that we taught in this video. So thank you so much for watching. Hope you enjoyed it. We'll see you back on this channel real soon. Make sure to have fun in your garage.